Hello, and welcome to this prezi presentation on the cardiac electrical conduction system. This presentation will cover cardiac cells, the conduction system, and how these show up on an EKG. First, let's discuss the cardiac cells. These cells consist of pacemaker cells and myocardial cells. Pacemaker cells are located in the electrical conduction system of the heart. They can be found in the sinoatrial node, the atrioventricular node, and the Purkinje fibers. These cells will produce a rhythmic impulse for the myocardial cells to react to. The pacemaker cells also possess excitability as well as conductivity. The myocardial cells possess contractility, which the pacemaker cells do not. This means that the myocardial cells are able to contract, thus causing the heart as a whole to contract or beat. The myocardial cells also possess excitability as well as conductivity. All cardiac cells, including pacemaker cells and myocardial cells, possess excitability as well as conductivity. Excitability is the ability of the cells to respond to an electrical impulse. Conductivity is the ability of the cells to transmit the electrical impulse to other cells. Next, let's look at the electrical conduction system. The electrical conduction system consists of the sinoatrial node, located here, the atrioventricular node, located here, the bundle of His, which is located here, the left bundle branch, located here, the right bundle branch, located here, as well as the Purkinje fibers, which are located here. First, let's discuss the sinoatrial node. The sinoatrial node is also known as the SA node. The SA node is located in the upper right atrium of the heart. The SA node has the highest level of automaticity, meaning that it fires the fastest. The function of the SA node is to maintain a normal heart rate and rhythm of 60 to 100 beats per minute. Electrical stimulus is carried through the left atrium by the Bachmann's bundle, and the electrical stimulus is carried through the right atrium by the internodal tracts. It's important to note that the SA node is influenced by the sympathetic nervous system. So the sympathetic nervous system can increase the heart rate, and the parasympathetic nervous system can decrease the heart rate. After the electrical impulse is produced by the SA node, it travels down the right atrium to the atrioventricular node, or the AV node, which is located at the junction of the right atrium and the right ventricle on the wall between the left and right atrium. When the electrical signal reaches the AV node, it is slowed down just enough to allow the atrium to empty and the ventricles to fill. In addition to these functions, the AV node is also able to block some of the impulses from the SA node if it is producing them too quickly. This protects the ventricles from increasing to a rate that is too rapid to maintain. In the event that the SA node is unable to produce an electrical signal, the AV node still possesses the ability to create an electrical impulse. If this happens, the heart rate will generally be slower at 40 to 60 beats per minute. Next comes the bundle of His and the bundle branches. The electrical impulse travels through the bundle of His and to the left and right bundle branches. The bundle of His is located in the septum between the left and right ventricles. The left and right bundle branches travel down the left and right ventricles respectively. Finally, we reach the Purkinje fibers. The Purkinje fibers are small pathways embedded into the ventricles. In the event that the SA node and the AV node are unable to be the pacemaker, the Purkinje fibers will take over as the pacemaker of the heart with a rate of 20 to 40 beats per minute. So how does this show up on an EKG? Let's take a look. The electrical impulse travels from the SA node and through the atria via the Bachmann's bundle and the internodal tracts. This appears on the EKG strip as the P wave. In a healthy heart, this electrical stimulation will make the atria contract. So in other words, the P wave is the depolarization of the atria. The QRS complex is formed as the electrical stimulus travels through the ventricles. This pathway involves going through the AV node, down the bundle of His, through the left and right bundle branches, and finally to the Purkinje fibers. In other words, the QRS complex represents ventricular depolarization, or a ventricular beat in the healthy heart. At the same time as the ventricular depolarization, atrial repolarization also occurs. Because the depolarization of the ventricles is a much stronger electrical signal than the repolarization of the atria, the repolarization of the atria is unseen as it is masked by the depolarization of the ventricle on the EKG strip. Finally, we will see the T wave, which represents the repolarization of the ventricles. Thank you for watching this prezi presentation. I hope you enjoyed it, and I hope you have a good rest of your day.